Question 10. So, fairly tricky, but not impossible. Let's start off by tidying up this differential. So, this first term can be thought of as 3 over 2 x to the half, and this second term can be thought of as minusing 9 over 4 times x to the minus a half, and then plus r2. So that's a reworked f dash x. Now, to find f of x, we need to integrate the differential. So how do we integrate? Well, we raise the power by 1 and and divide by this new power. So we raise the power to 3 over 2 and divide by this new power. With the second term, we raise the power by 1 to plus a half, divide by this new power, and plus 2 becomes plus 2x, and then don't forget the constant, the unknown constant. So just tidying up this f of x, well, these 3 over 2's cancel, so our first term is just x to the power of 3 over 2. Dividing by a half is the same as multiplying by 2. 9 over 4 times 2 is 9 over 2, hence why we've got minus 9 over 2 x to the half plus 2x plus c. Now, to fully to complete this, we need to work out what c is, and we can do this because we know a point on the line, on the curve. We know when x is 4, y is 9. So 9 equals, and then we just substitute 4 into each of the x's. So 4 to the power of 3 over 2, remember this is square rooting and then cubing. Square root of 4 is 2, 2 cubed is 8. 4 to the half just means the square root of 4, which is 2. And 2 lots of 9 over 2 is 9, so we're minusing 9, plus 8 plus c. So 9 equals 8 minus 9 plus 8 plus c, allowing us to work out that c equals 2. So our final answer for f of x is exactly what we had here, but instead of plus 2 c on the end, we now have plus 2 on the end because we've worked out that c is plus 2. Now, it's just worth gathering your thoughts, I think, for part B before we launch in. We've got some curve, and we're told that the normal to the curve is parallel to this line here. So let's start off by working out the gradient of the normal, which is going to have the same gradient as the gradient of this parallel line here. So what is the gradient of this? Well, let's turn it into the format y equals mx plus c. So let's first of all take away x from both sides and then divide by 2. So we're making y the subject. So this is now in the format of y equals mx plus c. So our m is minus a half and our plus c is 0. So the gradient of the normal is minus a half. How do we work out the gradient of a tangent? Well, we flip it over and change the sign. So the gradient of the tangent equals plus 2. Now, we know that the differential allows us to work out the gradient at any point on the curve. And we're interested in the point where the gradient equals 2. So we can set the differential to equaling 2. So this equals 2. Now, fortunately, this sort of falls away and becomes quite easy because we can just take away 2 from both sides, meaning this term plus this term equals 0. So adding this term to both sides, we get 3 root x over 2 equals 9 over 4 root x. Now, if we choose to multiply both left and right hand side by 4 root x, that's going to undo both these denominators. So considering this term here, we've got 4 times 3 times root x on the numerator. So that's 12x. 12x divided by 2 is 6x. And on our right hand side, well, the 4 root x cancels with the 4 root x, leaving us with 9. So 6x equals 9. Dividing by 6, x equals 9 over 6, which is 3 over 2. So the x coordinate of P is 3 over 2.